Welcome to my projectbazaar.com. Let me discuss about the process two-way OFDM-based nonlinear amplify and forward relay systems. Let me discuss about the abstract of the project. The Amplify and Forward Relay Protocol is a protocol defined for wireless cooperative communications, an example of a wireless communication network in which cooperation improves the performance of the system is the relay network. Cooperation happens when a direct communication between a source and a destination is improved due to the help provided by the neighboring node. Thus, this neighboring node is denoted as a relay when that has no data of its own to transmit, or it can be a node that has data of its own to transmit, but it can help with the communication between S and D. Employing relays for communication between a source and a destination increases diversity, owing to the additional paths for the signals to traverse, and improves coverage once a direct link between the source and the destination becomes too weak. The Amplify and Forward Relay Protocol is a protocol defined for wireless cooperative communication. Proposed system two-way relay networks are designed based on the optimization of relay networks. The probabilities are analyzed with the fixed gain and the variable gain. A relay channel is a probability model, the communication between a sender and a receiver, aided by one or more intermediate relay nodes. Orthogonal frequency division multiplexing is a form of signal modulation that divides a high data rate modulating stream, placing them onto many slow modulated narrowband close spaced subcarriers. Orthogonal frequency division multiplexing or OFDM is a modulation format that is being used for many of the latest wireless and telecommunication standards. The main causes of intersymbol interference are multipath propagation or nonlinear frequency in channels. Adaptive modulation systems invariably require some channel state information at the transmitter. Let me discuss about the flow diagram for our process. Initially, in the system model has been decided. In first time slot of the system model, initially OFDM symbols are processed for A and B nodes, where A and B denotes the input constellation symbols. For modulation, QPSK modulation is used. Then apply the IFFD, in which the Fourier transform breaks the signal into different frequency bins by multiplying the signal with the series of sinusoidals. Followed the above mentioned process, can add the cyclic prefix to each modulated symbols, can mitigate the problems of ISI and ICC by removing them altogether. System has been considered at a subcarrier level. Then the cyclic prefix removal process have been performed, and apply the FFT at the receiver side. The received signal at the relay on the subcarrier is given. Then the amplification model performed by applying the amplification factor GK. GK is the kth subcarrier for FG scenario as well as VG scenario has been derived. Finally, the total signal power to noise ratio after amplification has been calculated. Then the time domain output of the considering distortion term. In the second time slot of the received signal on the subcarrier at the node for FG and VG system has been analyzed. Finally, the estimation of outage probability. Here both the FG outage probability and VG outage probability has been analyzed. Outage probability of FG system at node B considering the instantaneous SNR per hop, and the outage probability on every subcarrier at node B as, and interference assessment. Outage probability at node A and B can be defined. Finally, the performance has been analyzed. Analyzes the performance of the outage probability at node B, at node A and node B, and interference assessment diagram has been calculated. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, right click the file and run for executing this process. Here we perform and derive the outage probability for fixed gain and variable gains. Here, consider the amplify and forward relay networks. After executing this process, we analyze the output, and this is the input signal generation. Here, this is the IFFT result. After performing the IFFT operation, we obtain the modified input signal of our IFFT process, and this is the cyclic prefix insertion. With the results of IFFT, we can add the cyclic prefix at the IFFT result, and this is the cyclic prefix removal result. This is the resultant of the removal of cyclic prefix for our signal, and this is the numerical outage probability for the FG system by varying the Pmax ratio from 20, 40 and 60 dB. Here this graph has been analyzed by varying the epsilon AR and BR, and we analyze the numerical outage probability, and this is the numerical outage probability for the BG system by varying the Pmax ratio, and this is the FG total outage probability when gains are applied at the relay by varying the sigma value, and this is the BG total outage probability when gains are applied at the relay of our system. Here, by varying the Pmax value, we analyze the result, and finally this is the graph for average, that is interference removal assessment graph, by comparing the results with upper bound and also our interference assessment result. Thank you.